Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is deploying, monitoring, and securing applications on Kubernetes. Our speaker today is Bruno Andrade, who is the founder of Shippa. Bruno, thank you so much for joining me today. Really appreciate it.
Thank you for having me.
All right, well, I know you have a great presentation on tap, so I'm gonna put myself on mute, sit in the background, and let you get to it.
Sounds good. No, thanks for having me today. And as you mentioned, we're going to be covering on the deployment and management and monitoring of the applications on Kubernetes. But I think before we get to that, it's important to understand a little bit of a history, right? And when we started putting our thoughts together on how to approach maybe differently the deployment and operations of the applications on Kubernetes environments, it was interesting to chat and discuss with a lot of users and interview them. And one thing we learned was that if you look at the evolution of application delivery, the platform team has historically always been building platforms, right? If we go back to the time of our virtual machines, like if it was a long time ago, but it's still some time ago. If we go back then and we look at the data center VMs, we as platform engineers, we spent a lot of time basically building Chef, Puppet, or Ansible scripts to try and automate the delivery of virtual machines, install packages, so we could get our environments out there quickly. And the goal has always been to support our developers so they can now deploy their applications faster, so business can keep moving forward. And we spent a lot of time doing that, and that was great. We learned a lot. And when we started feeling comfortable, the developers basically came back and say, hey, there is now something called cloud, and we really need to get into that because our environment is just not fast enough. So there we go. As a platform engineering team, we drop a lot of what we built before, and we start doing it all over again. But now we're learning the cloud APIs, we're learning Terraform, different technologies, and we're building all of our automations and controls again in order to get applications deployed faster and get our environments faster for our developers. And the same thing happened again. And we learned that it's a cycle, right? When we got comfortable with that, now we have developers coming back and say, hey, we have something even faster than spinning up cloud images. We have containers, and we really need to get this Docker and Kubernetes technology internally. And here we go again. All over, we drop a lot of what we built before, and we start rebuilding things again. But we quickly learned that Docker and Kubernetes is a different beast from what we used before, in a sense that installing Kubernetes is not enough for our developers to be able to deploy their applications. We quickly learned that now we need to install routing, ingress, monitoring. We need to plug this into our CI/CD pipeline. We need to automate more scripts with Terraform to try and bring these things together. So the level of complexity, it's very different than before. It's a different ballgame. And we saw that a lot of the companies there that started going through that journey, they started looking at PaaS. So your platform as a service to try and reduce a lot of that work and speed up and bring the benefits, such as Heroku or even OpenShift. And they are great. I think they showed us the way to go or the path, and they brought some functionality such as their own CI/CD engine to make things easier. They brought some functionality such as multi-tenancy and RBAC, automated routing, and while these are great, people started now seeing what happens when they start using them at scale, right? They are not flexible solutions. They basically lock you down into vendors, because if you use OpenShift, you can only use OpenShift clusters, or Heroku, the same thing. And it ends up being expensive, not only from a cost perspective, but also from a resource perspective. This is not something that you can hire people out in the market that are very experienced on OpenShift or very experienced on Heroku. And it is hard enough already to find Kubernetes experienced professionals out there. So imagine this, and it becomes resource intensive. They consume a lot of memory. It's really hard to manage, to migrate versions, so on and so forth. And at the end of the day, while these functionalities, they help you deliver results faster, we learned that these functionalities are actually table stakes. And at the end of the day, when you start implementing the paths to have this table stakes functionality, you start running to the lack of extensibility and ability to support an evolving ecosystem. Because reality is, if you're implementing something today, such as Kubernetes, is because you are changing what you implemented yesterday. So there's a big chance that tomorrow your developers are going to come and say, hey, forget about Kubernetes. We need something smaller and faster, right? So you need something that extends and supports that evolving ecosystem. So here you are, after a year and a half to 2 years, basically building Kubernetes, all the components together, you give your developers Kubernetes as the interface. And what happens is, when they're deploying the first application or the first 5 applications, this is fine. But once they start scaling that number, they realize that they have that oh man moment, that they realize that they are now being pulled down into the infrastructure level, where they have to learn what an ingress is, what secrets are, services, deployment sets, config maps, and others, all in addition to their application code. And now they also have to learn Helm, GitOps, Terraform to automate their applications. So it becomes really complex at scale. And what we're seeing is that developers are coming back and saying that development and deployment of applications, they have become more complex than before, and that they are spending a lot more time on functionalities and developing things that are not core to what they are or their function, basically developing infrastructure related objects, which I agree with them. They have their point. And because they are now tasked with doing this, building those infrastructure related objects, the possibility of pushing misconfigured objects into production clusters is just real, and we see that happening a lot. So this is where most of the organizations are from a development perspective. And when we look from a platform engineering perspective or DevOps, we spent a year and a half or 2 years basically putting together our different clusters, monitoring security and all. But as these objects, they start landing in our cluster and they start to scale to maybe dozens or hundreds of applications and then thousands and thousands of objects, basically we quickly learned that enforcing policies and guardrails around them becomes really challenging, because now you're dealing with a lot of objects rather than an application like we used to before. And in order to do that and try to mitigate a little bit of the risk, we end up building more YAMLs, more script, more Terraforms, and more Git repos to manage this. So we just add complexity to what was complex already. Application support becomes challenged, and we're now getting pressure from the developers. And the question that they are coming back to us is, can you build another platform? So basically, all of this to go back to the same point as before, in the same cycle as before. Build something new, drop what you have. So we started thinking about what's a different way to deal with this. And we started thinking about an application management framework instead of rebuilding things. And when we think of an application management framework from a platform operator perspective, you have your table stakes type of functionalities, like we saw before, such as RBAC, connections to third-party apps, automatic routing and monitoring. And these are great, but they are not enough to be called an application framework. They need to have integrated security. They need to have multi-cluster support, because reality is, if you start using Kubernetes now, you're probably going to add different clusters, either in the same cloud or different cloud vendors, manage Kubernetes clusters and so on. And it needs to be integrated into your existing stack, right? You can't rip and replace everything, your CI pipeline and your monitoring stack. But if an application management framework to be effective, it needs to integrate into your existing stack. And it needs to fix the last mile deployment, A lot of us today here on this call, I'm sure we spend a lot of time building Terraform scripts, Helm charts, YAML files, basically to bridge the gap between our CI/CD pipeline and Kubernetes. So that application framework to be effective also needs to change that. And it needs to be extensible in a way that if tomorrow I want to change clusters, I can do that effectively without impacting my developers. And from an application developer perspective, we look at some of the table stakes functionalities as well, such as logging, monitoring, support to canary and others. But developers also need to go beyond. They need to focus on the application code rather than focusing on coding and building a bunch of objects. They need to have an application framework that doesn't change their workflow. So they need to keep using the same CI/CD pipelines or the same Git repo and so on and so forth. And they don't need, even though security has to be there, it has to be automated in a way that developers, they don't need to worry about it. And they need to have better observability at the app level, not at the object level. And it also needs to be extensible. So if we look at it, this is great. This is a framework, but how do we implement a framework? Let's say I'm a platform operator in an organization now. What I do is I create a framework A, and within that framework A, I basically abstract it completely away from Kubernetes. I just say, hey, this is my framework. These are the functionalities or the properties that my framework should enforce when applications are deployed through it, such as how much memory and CPU my applications can consume, what level of security scans, and any exceptions that you want to open, which teams can use it, connections to third-party services, all the way down to network policies, and so on and so forth. And this is all very abstracted from Kubernetes. You're defining application-level policies. Once you define that framework, you can attach that framework to a Kubernetes cluster you already have in place. In this case, we're mentioning GKE. But reality is, one single framework and rule is not enough for you to be able to address the different requirements that you have from different teams or different applications. So we as a platform operator, we can now define different frameworks with different properties and apply these frameworks to different clusters that we have. And what happens is, as these frameworks, they are attached to your clusters, they automatically start providing you that application framework that we mentioned before. And the other great part of it is that they start attaching your applications deployed using it to your existing stack, such as Datadog, New Relic, Jenkins, Slack, and others. From a developer standpoint, they keep using their same Git repo, their same CI/CD platform. But what happens now is, instead of you building the bridge between your CI/CD pipeline and Kubernetes, for example, with a bunch of YAMLs and Terraforms, what you're doing now, you're just connecting the CI pipeline to these frameworks. And now what happens as well is your developers, they don't need to build a single Kubernetes YAML file. They actually don't even know what type of cluster is running. They don't even know if it's Kubernetes running underneath the framework. And as soon as they push code, basically these frameworks are going to start building all the objects automatically, deploying them all, and so on and so forth. So these are some of the benefits, and what we're looking for at the end of the day, when you start implementing the framework, it helps you accelerate Kubernetes adoption. There's no need anymore for your developers to create YAML files and objects. You remove a lot of the custom scripts that you had to build and put in place that becomes really hard to manage for your app deployment. You get your developer now, we as a platform team or a DevOps team, we are the champions because we allow our application delivery team or our developers to focus on applications rather than infrastructure. And we as a platform team or DevOps, we keep on focus on controls, security, performance, and cost rather than building a bunch of custom scripts. And last but not least, we're focusing on delivering developer experience and speed at the same time that we as a platform team, we're implementing an extensible application framework. But that's enough for slides. I don't want to bore you to death. And we'll jump on to a quick demo of Sheepa to see how actually that happens and how that works. What you can see in front of you right now is basically Sheepa's dashboard. And Sheepa has basically two operating interfaces. One is the CLI, and the second one is the dashboard itself. Here in the dashboard, you can see some information about the size of your environment, such as nodes, clusters, and others. You can see how your applications are distributed geographically. So if you are a company that you have different clusters in different locations, you can actually see how your apps are distributed. You can see the node providers, so basically the cluster providers. If you're using AKS, EKS, GKE, or OKE, and others, you can plug them into Shippa, and Shippa is going to give you the analysis of these clusters. You can see what's happening over the last few days, for example, in terms of deployment. So who's deploying what? And you can also see some security info and so on and so forth. As mentioned before, everything on Shippa revolves around the frameworks you create, which inside Shippa, they're basically called pools. And when defining these pools, as mentioned during the presentation, you can insert things such as what type of plan for CPU and memory that you want to use. You can also attach network policies, application quota, so on and so forth. Once these are created, the pools are created and defined, you can attach your clusters to it. And your clusters may be coming from EKS, AKS, GKE, or any other cloud, and you can attach these clusters to the pool. One thing that you can use as well is multiple pools or multiple frameworks within the same cluster, in a way that you can use pools for different purposes, such as development, QA, and production, or you can use pools for environments such as multi-tenants, so each user or each team can have their different pools, or you can use pools for different geolocation of your apps, or even different pools for different projects. So you can deploy, for example, a pool called e-commerce, and then within that e-commerce pool, you can deploy all your services related to the e-commerce app. Once this is done, we can give access to our developers. And our developers can now start also deploying their apps, monitoring their apps, and so on and so forth. Our developers can use both as well, the front-end interface or the dashboard, as well as the CLI interface. When using the CLI interface, let's see an example. Here in front of me, I have my Ruby application. Let me just make it larger so everyone can basically see it. Okay, great. So I have my Ruby application. And as a developer, I don't know what is actually tied to the pool. So I don't know if it's a GKE, AKS, EKS, so on and so forth. Me as a developer, I don't have to worry about that. And I have here my Ruby code. And you're gonna see that within my Ruby code, I don't have any Kubernetes object YAML file whatsoever. Well, to be honest and fair, I do have a file called Shippa YAML. And within that Shippa YAML file, I can have two things. One is hooks that I want to run when my image is being built and my application is being deployed, or basically a health check. So every time my application is deployed, it runs a health check on a specific path. But the Shippa YAML file is completely optional. If the developer don't want to put it there, he doesn't need to. So I have my application here. So how do I get this over to Shippa? Basically, there are a couple of ways. You can do that directly from your CI pipeline, from your CLI, as well as from your CI pipeline, which I'm going to show in a minute. If we say Shippa app create, and I'll say maybe DevOps, and I'll say it's a Ruby app. The owner is going to be admin, the team. So if I have access to multiple teams, or my platform team gave me access to multiple teams, I can choose which one is going to be the owner of my app. And last but not least, the pool where I want to deploy this application, or the framework I created. We can choose one from the list. So I'll pick dev, basically, which is tied to a GKE cluster. Great. My application has been created successfully. But if I go into the application part, let me search for it, DevOps, I see this is actually empty and it shows idle. And the reason is because no code has been deployed yet. So I'm going to run the deployment directly from my CLI, and I'll show how to do that from the CI pipeline as well, but just so you have an idea. So I'll do Shipa app deploy, flag A, it's called DevOps, and I'll deploy these local files that I have here. So basically my Ruby app. You're going to see that I don't have a Docker file. In that case, when I'm deploying directly from source, Shipa will create the Docker file and the Docker images automatically for you. It will install all the dependencies and requirements that you have listed in the gem files, for example, or requirements.txt file if it's a Python app, and so on and so forth. So your developers, they don't even need to be concerned about building their own images. And as these applications are deployed, Shipa will automatically enforce all the requirements that your platform engineering team define at the pool level, such as the security scan, which teams can have access to it, network policies, so on and so forth. So you as a platform engineering team or DevOps team, you know that every app deployed basically has the requirements that you need. And while the deployment is ready, let's go back to an application that is already deployed. One of the things that we use to show users what Shipa is actually doing in the background is our application dependency map. In a way that basically this is the code that the developer is actually delivering. And here you can see all the objects that Shipa is creating, such as all the container units that Shipa is automatically creating and deploying, the images that Shipa created and also deployed in order to support your application, all the application dependencies files. So in this case, I think this one was a Golang app that you can see which files were deployed. You can see the related Kubernetes objects, such as the services created, the secrets, all the pods in Kubernetes, the status, and all the detailed information, ingress info, all the way down to even what type of hooks your application is running every time it's restarted, to the specific commands that your application is running every time it's restarted. And one of the great things about it is that when talking to a lot of users, we learned that a lot of them, they were coming back and saying, what is an application on Kubernetes, right? And the reason was, and they were saying that we need better observability, better monitoring. And one of the main reasons was because once your application is deployed, it becomes a bunch of just spread out living objects in your clusters that many times they are not directly related to each other. So it's really hard to understand the architecture or the anatomy of your application once it's deployed, the status, where to start, what is what. So giving the application dependencies makes it really easy for your developers to understand what's happening, as well as for your SRE and support team to understand if there is an error and how to troubleshoot. That is part of it. The second one is once we go into the application, we can see detailed information again, such as what amount of memory and CPU my applications are consuming, who is the owner, so on and so forth. And when we built it, we built it with a workflow in mind, in a way that you understand the metadata, but now you also start understanding the application level information, such as the transactions and the performance of your apps, such as status codes per second that you're receiving, requests per second, response time, so on and so forth. So you can better understand the status of your application. And Shipa allows you also to build SLIs and SLOs for auto scale based on those metrics if you want to. You are also going to notice that you can see the resources. So how much memory your applications are actually consuming. You at the pool level define the cap, but you can see here if your application is reaching that cap or if it's way below. So it makes it a lot easier for your platform engineering team and your developers to adjust the amount of resources you are consuming. The other one that you're going to see is basically the units. So you understand the containers that your application is running and the status and information about it. If you're running a distributed cluster, you can see the node, the location of your apps. And another important part for both the developer as well as the SRE and platform teams is you can understand the life cycle of your applications, such as when my application was created, by who, as well as when every deployment happened, and everything is going to be related and put here, such as when your application scaled up or scaled down, new deployments arrive, and you have an audit history by who did it, when that happened, the result, and you have basically the log attached to it. So you can quickly understand what is happening with your app. And if there are errors and issues, one of the things you can do directly from here is perform a rollback of your application. And the rollback is going to happen based on Git history. So your Git operations basically. And Sheepa is going to automatically rebuild your application based on that past Git and attach the routing, attach monitoring, and so on, and give that back to you up and running. The other tab that you're going to see is basically the security tab. And the security tab is going to again be tied to your pool definition. So the level of security that your platform engineering or DevOps team defines, such as at the code level or at the image layer, and any exceptions. If anything new is found, vulnerabilities are going to be listed here. So your team can take action and correct that for your application to be properly defined. The other point as well is you want to make sure that your application is integrated into your incident management stack. So directly from here, you can connect it into Slack, GitLab, PagerDuty, and others. So you can basically have a full life cycle and loop between your platform engineering team and your developers so they understand the application status. Last but not least, they can see and set also network policies, which by default follows the pool configuration, or you can basically change and define the ones that you want here. We can go back and see. Our application has completely deployed our DevOps app. So if we just refresh and we try to find our DevOps app, we can see this is running. We can see all the objects created related to that. And we're also going to see that it created an endpoint for our application. So Sheepa connects directly into your ingress controller and generates that for you as an endpoint. So your developers, they can access their applications directly from here at any time. And you can see that, again, me as a developer, I didn't have to worry about Kubernetes. I'm just pushing my code and my application. And Sheepa can give your developers very detailed information and control over the app, where they can basically generate certificates, they can build their apps, they can deploy, they can see the logs, they can give access even to other teams, such as an SRE through the app grant. If you're using multiple pools to tackle problems such as there are multiple environments, such as dev, QA, and production, you can move applications between pools with the Sheepa app move. So it gives very granular control to your developers around their applications. But now we understand that most of the folks here on this call, if not all, you already have a CI pipeline in place. Your code is basically coming from there and you want it integrated. And there are different ways to do that. Some of them are native, such as our partnership with Circle CI, where we have a native orb delivered with them that you can use to integrate. And some others that you have a Python library called Sheepa CI. And that Sheepa CI Python library allows your developers and your platform engineering team to basically deploy your application directly from here, directly from your CI pipeline. And actually, directly from your CI pipeline, you can do multiple things. You can create a pool, you can attach clusters, you can create the app deploy. So you even have total control directly from your CI pipeline. And not only straight out deployments of applications, but also canary type of deployment. So before, your developers, they were struggling around Istio, trying to understand the ingress, how it works, and how to define canary. Here in this case, basically you're deploying using 3 flags, so your developers can easily achieve that. So that integrates into your existing pipeline. From a monitoring perspective, Sheepa is built on top of Prometheus, and it allows you to export metrics into an external Prometheus as well as into Datadog, New Relic, and others. The last few parts of Sheepa is it allows you basically to integrate into existing external services that you have. Such in this case, I have a Postgres managed version on GCE. So if me as a platform operating engineer or a DevOps engineer, I can create that connection and give it to my users. My developers can come in here, create their own instances inside that Postgres service and bind it to their applications. So they don't have to fiddle around config maps, so on and so forth, and they can quickly start consuming that service. And last but not least, if you're using volumes or persistent type of applications, you can create your volumes directly here and bind them in the same way to your applications, so it becomes really developer friendly. So now with all of that, you basically have an application framework that you can distribute and create your applications while allowing your developers to focus primarily on code and just the code. And we as a platform engineering team or DevOps team to swap components, swap clusters, run updates, and even insert new clusters and new cloud vendors that we would like, but without impacting the developer framework or the application delivery. So we make it extensible and we make it modular, and we increase the speed that we're adopting Kubernetes in our infrastructure, in our organization. So from our end, that's it. I think that helps as an overview of Shipa and to understand how you can develop and deploy and monitor and operate your applications on Kubernetes using an application management framework.
All right, great. That's some neat stuff there. I love to watch those demos. There's so much stuff there that is just fascinating to me. So, but thank you very much for that great presentation. We have plenty of time for questions, guys. So if you do have a question for Bruno, go ahead and use your GoToWebinar control panel. We've gotten some in already, so I'm going to go ahead and dive right on in, and we'll see how far we get. Here is the first one. How does it handle, say, security scan of intermediate artifacts like Docker images, for instance? Is there a way to integrate existing tool stack of the company?
Yeah, that's right. It is possible to integrate your existing security stack. And we have users today that integrated with tools such as Twistlock, JFrog, X-Ray, and others. And to your question, when you create the pool, basically I have a file here. I usually like to show to make it easier for folks to understand. When you create a pool, either from the dashboard or from the CLI, you're basically defining what level of security scan you want, either at the code level or at the OS level, so the image, like the Docker image level, or both if you want. And any security vulnerabilities that you want to ignore, if any, you don't need to. So every time you're deploying, either directly from source or if you're deploying an existing Docker image that you have, Shipa is going to run that security scan at deployment time and in an ongoing basis. And that can be either Shipa's internal security scan, which ships with Claire, or it can be the one that Shipa is using or leveraging from your organization, the external ones, such as Twistlock, X-Ray, and others. So I hope that helps with that question.
Excellent. Okay, next question here. This is regarding the resource loads. My understanding is that Kubernetes has a load balancing feature to kill nodes that are not in use, and you can use it. You can set it to 0, meaning if your app is not running, it releases all your resources. So in Shipa, why do engineers need to manually set resource limits? Or maybe I understood the comments incorrectly.
No, that's an awesome question. So what we do is a lot of developers today, when they're building their YAML files to deploy their applications, what happens is they usually request the amount of memory and so on in there. And some of the organizations, if you look at the way they have it there, if they don't properly manage it at the Kubernetes level, you end up with a lot of resources that your developers requested that is actually not being used. So later it becomes really hard for you to kind of implement security and implement controls and reduce the amount of resources that are just being wasted. So with Shipa, in that case, you are imposing limits right at the get-go. So your developers are not going to come in and say, I need 1 gig for my app, for example, or this many CPUs. So you can implement some guardrails and controls. The other thing as well is because we drive a lot of the application auto scale either up or down, also based on the SLIs and SLOs, such as how many requests per second your application is receiving, the latency, and so on and so forth. You can implement more sophisticated, I would say, scale up and down, but you can definitely tie this up to Kubernetes capabilities. But this allows you to kind of implement some security and controls and then guardrails around the resource and scale up and down in a more kind of fashioned way, I would say.
All right, great. Next question here. Are there any restrictions to attach Kubernetes clusters? We use a custom Kubernetes cluster build with KOPS.
Definitely not. You can use managed Kubernetes such as GKE, AKS. You can go and use even K3s if you're talking about maybe dev environments or edge. But if you have also clusters that you built with kops, for example, you can definitely do that. As long as the API is available and Shippa can reach that API, you can definitely attach that cluster to a pool that you have on Shippa and start using it to deploy the apps.
All right. All right, plenty of time for questions, guys. If you do have one, go ahead and send it on in. Next question. Let's see. How can Shippa help to think at an application context rather than object infrastructure context?
Yeah, I think that's one of the biggest points with Shippa, and not only with Shippa, but if you look at it, that it is a problem as you start scaling Kubernetes across a bunch of companies, right? Now you're getting your developers to basically build a bunch of YAMLs, deployment sets, stateful sets if you need volumes, ingress rules, and if you need canary, all your developers are going to be into the trenches with Istio and so on and so forth. So now your developers are really thinking about infrastructure and object, right, and Kubernetes itself. With Shippa, like during the demo, me as a developer, I just have my Ruby app, and it's the same thing if I have a Python app or Go app, or even if I have my Docker image already built with my app, I'm just deploying that. I don't need to know ingress controllers. I don't need to grow to know, learn, and create and manage deployment sets, so on and so forth. So it allows me to focus just on my code while security, guardrails, controls, resources, and objects, and everything else is being managed automatically by Shippa. So every time my application hits the Shippa pool is responsible for creating all of that in the cluster that is attached. So your developer can focus primarily on that.
All right. Next question here. So many great questions. To add users, can we use an external identity provider like Azure IDS, AWS IAM, or another?
Yep, definitely. You can use Azure IDS, AWS IAM as well. You can use the cloud provider ones, basically, as well as you can use GitHub or GitLab as authentication methods, or you can basically use a native one, which is from Shippa. We just ship it out of the box, so your developers can test quickly and get up and running quickly and get their applications deployed quickly, I would say. So have that first experience. But then as you start building into the enterprise, you can definitely connect it to your existing IAM providers.
Excellent. All right. Next question. Can we monitor logs using Splunk kind of tools generated by the container platform?
Definitely. So you can monitor it using tools such as Splunk, or you can monitor it using tools such as maybe Logs.io, Datadog. So Shippa provides those integrations out of the box. And even if there is one tool that Shippa does not support right away, you have something called Shippa plugins that allows you basically to build plugins and connect your applications into different tools. So Shippa is extensible, but yeah, short answer to your question, you definitely can send the application logs and container logs to external log apps or monitoring apps.
Excellent. All righty then. Next question. How do you handle project releases and release upgrades, both of external components and most importantly on internal builds?
That's a good question. So we tie this up directly to your CI pipeline. In a way that your CI pipeline, every time there is a merge, your CI pipeline can kick off a new test and build and a new deploy in Shippa. These deployments can happen across different pools, for example. So you can have pools for maybe internal apps and pools for external apps, where you can control network policies around these apps. So you can have granular control around things such as which apps can connect to this application that is being deployed right now. If we see one example here, I'm saying this is the ingress controller. This is the other application that can connect to it on specific port protocol. Here's the egress. So you can actually use that all automated from your CI pipeline. So every time there is a new deployment, either internal or external, or there are new releases, you can use that as as controls as well.
Excellent. Next question. We have so many good ones. How to make secure environment YAML files and connection strings.
How to make secure environments for YAML files and connection strings. Okay, so let me see if I understand it right. So when in terms of security environments, every communication between Shippa and your CI pipeline, as well as your Kubernetes clusters, all these connections are basically encrypted all the way on both ways. Also, in terms of connection strings, if I understand it correctly, if you want to pass, for example, environment variables to your application, you can do it two ways. So, for example, when you have a Shippa env, oops, if I can type, you have a Shippa env, which basically can insert or inject environment variables into your application, so your code can consume it. The other option as well is we have integrations into things such as Vault from HashiCorp and others that you can use also to pass encrypted connection strings as well to your application. So there are different options in terms of handling that.
All right, let's see. Wow, they just keep coming here. Okay, I have to set up KBRNTS. I'm not quite sure what that is for my application for next upgrade. What are the things needed to get started? I'm completely new to KBRNTS.
Oh yeah, I think that's probably Kubernetes.
Yeah, I think so. You're right. Yeah.
I think that's a very that's a big question, right? And I think there is a lot
That
to
is a huge
unpack
question.
there. Yeah, I think you're gonna have to go through what type of applications you're gonna be running, how to connect to your CI pipeline, what Kubernetes provider do you want to use? Do you want to use managed Kubernetes providers that frees you up from a lot of the infrastructure management piece, but at the same time doesn't give you kind of cluster related flexibility in a way that you can automate it? So there are many components to that question that I think you have to unpack, but to the time that you reach the app deployment. Happy to have a separate chat and share some of the thoughts on that, but it is definitely a big question.
Okay. All right. All right. Okay, well, I think I'm going to give you a break. I think this is pretty much all the questions that we're going to have for today's webinar. If we didn't get to your question, or Manish, I know you had some questions that you want to address offline with Bruno, so I'm sure he's going to get a copy of all the questions, so I'm sure he'll follow up with you offline to get your question answered. So thank you to everybody who did submit questions. There were some really great ones. I was surprised at how many questions came in, which is awesome. I love that. But I do thank everybody for submitting questions. If you have a question for Bruno before the end of the webinar, you can still go ahead and put it into the GoToWebinar control panel. And I said before, he's going to get a copy of the question, so he will definitely get it. Also want to remind the audience that today's event is being recorded or has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand after today's webinar. So if you missed, as I said, if you missed any or all of it, if you just want to watch it again, you will be able to do so. The webinar is also going to be living on the devops.com website, so you can go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, before we close things out, I did mention that we were going to be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and get to that now. Our first winner today is David H. Congratulations, David. Second winner today is Edward Z. Congratulations, Edward. Third winner today is Luca M. Congratulations, Luca. And our final winner today is Laura F. Congratulations, Laura. I will we'll be following up with all 4 of you offline to get your Amazon gift card over to you. Check your inbox. If you don't see it in your inbox, please check your spam folder. Bruno, thank you for such a great presentation. Lots of great information. I love to see the demos, and judging from the number and quality of questions that we got, I know the audience got a lot out of it as well. So thanks again, really appreciate it.
No, thank you for the time. Really glad to do it and participate.
Okay. All right, great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.
Thank you.